Well, today we've been looking at methods of heat transfer. We see there are three chief methods of heat transfer: conduction, convection and radiation. The differences between conduction and convection, as we've seen, are somewhat difficult. In conduction, atoms and molecules pass on their excitement to neighbouring atoms and molecules without themselves being transported, whereas in convection, mass transport happens and the molecules themselves transport the energy. Okay, so radiation is the last one, which was a method of energy transfer, which we saw involves the emission of electromagnetic radiation. This is how we receive heat from the sun, and it's how also we've used the cosmic background radiation to tell us about the universe. We looked at conduction and we saw that we can model conduction and we can work out a rate of heat flow, dq by dt, which equals minus Ka dt by dy, where K is the thermal conductivity and A is the surface area. Okay, so we looked in the later stages of the lecture at the thermal conductivity of a gas. Now remember, when you look through this derivation, that we've actually done this derivation considering the plus y direction. Following that should help to understand some of the signs that we're using and those sign conventions. So following that derivation through, we've seen that we can write the thermal conductivity K of a gas as the number of moles multiplied by the average velocity divided by 3, multiplied by the molar specific heat at constant volume, CV, multiplied by the mean free path, lambda. So it's important that we can, from this measurement of something bulk like the thermal conductivity, we can actually come out with an answer for what the size of the atoms and molecules are. Again, from macroscopic behaviour, we've been able to go back down and get information about the microscopic properties of average particles. When we finish, we look briefly at the end of the lecture at van der Waals equation. If you remember, van der Waals equation allowed us to correct the ideal gas law, i.e. PVM equals RT, to take into account the fact that the molecules are of finite size and also they interact with one another. So van der Waals equation gives us that P plus A over Vm squared multiplied by Vm minus B equals RT. A and B are tabulated constants that take into account the fact the molecules interact and the finite molecular volume. We've now finished looking at gases, and from the next lecture onwards we're going to look at properties of solids. We're going to look at stretching and those kinds of things to start with before moving on to look at electrical properties.